Here we have a digit reversal question. So when you reverse the digits of a certain two-digit number, you decrease its value by 63. Find the number if the sum of the digits is 11. So as mentioned before, when you have these questions, you can right away say the original is 10 times the tens digit plus the units digit, and the reverse is going to be switching the t and u. That's going to be 10 times the units digit plus t. I'm actually going to start at the end here because this is an easy part to see. The sum of the digits is 11. That means t plus u equals 11. And then it says, when you reverse the digits of a certain two-digit number, you decrease its value by 63. So if you take the original and subtract 63, that will be the new or the reverse digit 1. Or maybe it's easier to think this way. The reverse is the original minus 63 because you're decreasing the value of it. So you're taking your original, decreasing the value by 63 is going to give you the new. And so now what you have is you have two equations. We're going to clean this bottom one up a little bit. And this one, let's write it down here. Let's go ahead and add 63 to both sides. That will give us 10t plus u equals 10u plus t plus 63. And then I'm going to get the u's and t's on the other side. Be careful to subtract from the right term. So 10u, subtract 10u from both sides, and then subtract t from both sides. That will leave us with 9t minus 9u equals 63. What I like about this, and this happens often, is all of these digits are divisible by 9. So we can divide both sides by 9. It just makes things a lot simpler because the numbers are smaller. So if that ever happens, if everything's divisible by the same number, go ahead and divide. This gives us t minus u equals 63 divided by 9 is 7. And now we have these two equations, which are going to be nice and easy to solve for, because this is set up very nicely for elimination. We're going to add. The u's will become 0. We have 2t equals equals 18. Divide both sides by 2. T equals 9. Plugging back into one of the originals, 9 plus u equals 11. So u has to equal 2. So find the number is the question. That means the original number. Well, that would be 9 and 2. Not tens digit is 9 and units digit is 2, 92. That is the algebra way of doing it. There's also a thinking through way of doing this. And the key is this over here. The sum of the digits is 11. So what we're going to do is we're going to come up with all possibilities of how the sum of the digits can be 11. So 1 plus 10 is 11. Well, 10 isn't a digit, so that doesn't work. So 2 and 9, 3 and 8, 4 and 7, 5 and 6, 6 and 5. So all I'm doing is picking two digits that add up to 11. And once you write them, you end up getting the reverse of them. All right, so it says, when you reverse the digits of a certain two-digit number, you decrease its value by 63. Well, if you decrease its value by 63, you have to start with a larger number and subtract its reverse. So you might think 65 minus 56. That's 11. That's not 11, that's 9. Or we could think 74 minus 47, or 83 minus 38, or 92 minus 29. They have to be 63 apart. Well, I would probably start with this one here because they have to be far apart, and when you do 92 minus 29, you get 63. And so we know the original was 92. So that's another way to think through that. Actually, the easier way.